Today on the Data Show, we're going to cover things like blue light filtering glasses, as well as the $1 billion climate disasters. Does the media really understand what they are doing when they use hyperbole to try to report this stuff? I think they do, and I think they do it every time. So, that and more on the Data Show. Welcome. Chris Greco. I'll be your host for the next 30 minutes. We'll be talking about different parts of data, what to do with it, how to collect it, how to really analyze it, and what to make of the media reporting of it. I guess the thing that disappoints me the most, and this is, I'm going to get on a soapbox here just for a second. I'm going to talk about these doctors, these MDs that are on these different media shows. And it would embarrass me to be an MD and to report the way they're reporting. I mean, they sit there and they basically talk about these different studies as if they are just absolutely factual, and they're not factual. Now, I heard today on one of the stations, one of the US media stations, they had a doctor on now. I think she's an OBGYN, but she was talking about different aspects. And all of a sudden, she started actually talking about the study. And she said, oh, there's some limitations with this. And I thought, that is the first time I have heard anybody on any station, whether it be a lawyer, that they have on the reporting thing, or a doctor, talk about the limitations of these studies. So good for them that they actually were able to do that, because I am getting sick and tired of these media, these talking heads sitting there talking about a study as if they really know what it's about, number one, which they don't. They're just reading off a teleprompter. So they have no idea what went into the study. That's number one. Number two is they're coming off as very a lot of veracity, and the idea that, hey, look, I'm sitting here in front of you and in your TV set while you're having dinner or whatever, and I'm telling you what's going on, and therefore you should believe me. And I'll tell you something. Right now, I'm afraid I don't believe much of what the U.S. media is saying. I just don't. I mean, if they say something, I got to check it. I got to get in and research it and do whatever. And so we're going to cover two of those things today. We're going to cover the blue light filtering glasses, and we're also going to cover the $1 billion climate disasters that are happening right now as we speak, with these whole things. And I've said in the past that I've really trusted the government data. And I'm going to show you here that this climate data that's being reported by NOAA, National Oceanic and Atmospheric Administration, I took a look at that data, and I'll tell you, I see some real issues with this data. Now I'm going to point them out to you. And yes, maybe I'm just not looking at the whole picture. Maybe the audience can go out there and they can kind of take a look at it, whatever. But I'm telling you that this is just shady. It's just plain shady. And they're putting this stuff out for the public, and I don't think the public is really checking it. I think they're kind of taking a look at this data and just believing it. You need to take a look at it in a really, really critical mode and take a look at this stuff. So without further ado, let's go to the first one, and that's the blue filtering light area. And this was done by the Cleveland Clinic, and it talks about, do blue light glasses really work? Now, this was November 2021. Now, recently, within the last week, they talked that blue light glasses do not work. There's no significant difference between a person wearing blue light glasses and not wearing blue light glasses. So, and this is as far back as 2021, they were talking about this type of thing. So I sit back and I go, well, during COVID and whatever else, a lot more people were using computers. They were taking a look at iPads, their cell phones all the time. So those types of things happen. Now, I have blue light filtering glasses. I was getting optical migraines before I got these blue light filtering glasses. Now, I'm not saying, and I don't want to say, because it would be basically anomalous, that it's based on one sample of me, that the optical migraines, they ceased or reduced drastically after I got blue light filtering glasses. That doesn't mean the blue light filtering glasses will get rid of optical migraines. It just means that that was, I attributed that reduction, that mitigation to those blue light filtering glasses. So Cleveland Clinic, they talked about it in different aspects, and talked about studies and all these things that go along with that. And then another area was NPR, and NPR actually brought in an individual. And again, this was 2021. So 2021 must have been a big deal with these blue light glasses, and then they brought them back again. So what exactly does that mean? Well, so what I did was I wanted to get a hold of the study. So I actually went and I got a hold of this study. This is the study. This is from the Cochrane Library. Cochrane Library, reputable study area. They do a lot of studies, different aspects. And they did a blue light filtering spectacle lenses for visual performance, sleep, macular health, right? And all this. And then it says, no, basically, the objective is to assess the effect of blue light filtering glasses. Search methods. We searched the Cochrane Central Registry of Controlled Trials, right? Ovid, clinicaltrials.gov, which is actually a very good repository of clinical trials. Every clinical trial should go to clinicaltrials.gov, but I don't think there's anything that makes that mandatory. So there's a lot of studies that are in fact missing. So what is this? This is called a meta study. It's a study of different studies. So in other words, they did not go out and sample people and all that. They went out and got these studies and then made it put it through a procedure, a process with which to select those that they wanted to select. So randomized controlled trials, right? All these things. But again, they're searching for different methods. So primary outcomes with a change in visual fatigue score, critical flicker, fusion, frequency, continuous eye columns, blah, blah, blah. Main results. We included 17 randomized control. So right here. Randomized, so it's RCT, randomized controlled trials. What does that mean? That means there's two different samples. There's a sample that's control, which means they do not get the therapy, and then there's another area that's basically the treated sample, which is those that get the therapy. So they did that, right? Ranging from 5 to 156 participants. Now, I'm going to tell you right now, the ones that have 5 participants, right, should not even be considered. I'm sorry. 5 is not a good sample. 5 is not adequate. 5 will never be adequate to be able to do those things. Now, how can I say that, right? Well, so let's just go to this real quick. We're going to go to the control aspect on this. What is control? What is power, right? Statistical power. So we're going to go ahead and take a look at this and take a look at the statistical power. So let's say that we want to have a statistical power, right? So we want to have a statistical power. It's going to be a 1 sample, although we can do 2 sample, but let's say 1 sample, right? Want to have power. So we'd say okay to this, and then we say the effect size. Now the effect size, the lower the effect size is, it's like a higher method of correlation. So you go actually lower with this. So let's say I want to have an effect size of 0.2, and my sample size is 5, right? So if I do that, look where my power is, 0.07. We should have 0.80 or better. 0.80 or better, we have 0.07. All right, so let's go with 156. Let's go with 156. What do I have? 0.70. It's getting better, but it's still not the 0.80 we want. So if they took samples between 5 and 156, it does not have the statistical power to be able to do what needs to be done to have an effect size that's really going to be a good effect size. And 0.2 is a good effect size. Now, a lot of people are going to sit there and say, well, Chris, wait a minute, 0.80 is a good correlation. This is the reverse of that. This is the reverse of that. So 0.2 would be like the same thing as being 0.80 correlation aspect. So that's why this is very important to be able to understand that. And the alpha is 0.05, which is fine. That's a normal. That's a standard alpha on this. Is type 1 error, right? Is or type 2 error, which is going to be the alpha here. So that's what's important. I just want to make sure that everybody understands that that's why it's very important to have a good sampling, because if you don't have a good sampling, then that's exactly what's going to happen. You're going to have a problem. So 5 to 156, well, that's a problem there. None of the studies had a low risk of bias. None of the studies had a low risk of bias. That Cochrane was basically a risk of bias in fact, Cochrane risk of bias is kind of the standard, for what it is. So I love the way they do this. They use a double negative, right? None of the studies had a low risk of bias. In all 7 Cochrane ROB1 domains. There's probably a better way of phrasing that. It would have been all of the studies had a high risk of bias in at least one Cochrane ROB1 domains. But see, I don't do that. None of the studies had a low risk bias. If you're reading that quickly, you don't get it. We judge 65% of the studies to have a high risk of bias due to outcome assessors not being masked. Detection bias. 65% of the studies have a high risk of bias due to detection bias. 59% to be high risk of bias of performance bias, as participants and personnel were not masked. Masked doesn't mean they were masked. It was basically masked from the data perspective, so everybody knew everybody. 35% of the studies were pre-registered on a trial registry. We did not perform meta-analysis for any of the outcome measures due to a lack of available quantitative data, heterogeneous study populations, and differences in intervention follow-up periods. I mean, take a look at this. I mean, I'll tell you what this shows. This shows that those studies that were done on blue light filtering they're not good studies. They're not. But yet they came up with a conclusion based on that. And this is amazing to me, because there may be a little difference in CFF with blue light filtering glasses compared to one study reported no significant difference. I mean, once you get past this, once you read this, the rest of this is almost unnecessary. It's like, wait a minute, you're saying right here that these studies were flawed, and you're taking those studies and you're putting them all together in a meta study, and that's flawed. It's flawed. I'm sorry, but this, the media needs to go out and they need to do some fact checking on this stuff. They do no fact checking on these studies, none. And it just amazes me, because the study people put this stuff together. They're trying to be as transparent as possible, and then you got the media that's basically feeding people, and people are sucking this up. They're like, oh yes, I'm going to get rid of my blue light filtering glasses. I'm going to get rid of them because look, I mean, the media says they're just no good. I mean, and it's like, wait a minute, no, that's not what they said. Well, yeah, that's what they said. So this is what's happening. So you have this blue light filtering thing that's going on, and everybody's sitting back going, well, I'm going to get rid of. It's like saying, someone did this study, and windshields just are not as effective as you think that they are. When you have this big, gigantic rock thrown through it, if you get a rock big enough, I can break your windshield. You know what that means? I can do that 100% of the time, which means that they're just no good. Well, they're no good against gigantic rocks being thrown at you. It doesn't mean they're no good. So, I mean, it's a situation where as a data person, and the thing is, I'm sorry, I don't see many people out there in the media or YouTube or whatever else doing this. I don't see many people doing that. And these are data people. You know what they're espousing? Well, you got to do Python, and you got to get R, and SAS is good, and SPSS is good, and here's something to do in Excel and whatever else. Wait a minute, time out. There's no application here. Look at these studies. Look at these things. I mean, it's ridiculous for you as an individual to sit there and say, I'm going to believe everything the media tells me based on one study. And again, what gets me is these doctors. They bring in these doctors. Remember that show where it had a bunch of doctors and they talked about that? That's gone. It's gone. The show is gone. There's no longer a show like that. All they do is they bring in these doctors as, talking heads, and they talk about different aspects, and then they walk away, basically verifying this study. verifying studies. I haven't heard them once say, the study just really is not as good as we think it is, and whatever else. So I mean, it's really hilarious to talk about this stuff. And one last thing that they talk about is, the author's conclusions here. Systematic review found that blue filter glass may not, doesn't say does not, it says may not attenuate symptoms of eye strain over short follow-up period, over a short follow-up period. They're very, very careful about what they do, which is good, right? Based on the current best available evidence, there is probably little or no effect of blue light filtering. Probably, they don't say it. They don't say there is. There is probably no light effect. It says there was no evidence from RCT publications relating to outcomes of contrast sensitivity, color dimmization, blah blah blah, serum melatonin levels, overall, and they go through all that. They go through all that stuff. So I mean, and then they go through a plain language aspect on this thing. So then plain language. Cochrane does a good job of this. Plain language summary. They go through it, different aspects and whatever else. One study, 17%. There's some evidence harmful effects that may be related to using blue light included headache. One study, 8%. Increased depressive systems. One study, 17%. Lowered mood. One study. This is one study now. One study, 5%. And discomfort wearing the glasses. Two studies, 22%. Hello, I've worn glasses all my life since I was 8. So I've worn them for over 60 years. And guess what? They're uncomfortable. Never going to be comfortable. So I mean, this is what's happening here. So it's just not what you would say is this great and glorious aspect. Now Cochrane, I think, did a great job. They did what they were supposed to do. They made sure that they did the study. They made sure they collected what they needed to collect. They made sure they did what they're supposed to do. I never, I've never blamed the study people on this. I blame the media totally and completely, absolutely, 100%. It is the media's problem. They want clickbait. They want to make sure people have some type of panic, an issue, a provocation, something to get people to read the articles. And that's what they do. And they do it for a reason. It's because they need the advertising dollars. They need the dollars. The more people that read this stuff, the more that they get paid. And they want to have that. So they make sure that these things are provocative. So that's why it's like, oh, you wear blue light glasses? Well, I wouldn't do that. I mean, look at, what is it, 15 years ago now? They said, oh, coffee, don't drink coffee. Oh, yeah, drink coffee. Oh, don't drink wine. You know where you can hear all this stuff? In my book. I have plenty of examples. Data analyst walks into a bar graph. www.lulu.com. Get my book. It will have an entire, all the examples that you want to have. You want to be predicting the past, all these different things. Take a look at the book. It's on Amazon too. I'm telling you, you'll enjoy it. It really is good. And I even do a study in there. I won't give it away, but I did a study and I did all the things, most of the things, every single little bit, no, probably, but most of the things that real studies do. And I came up with this ridiculous conclusion. And the thing is, that's what you come up with. If you don't do the studies, unless you have some type of bias or whatever else, you're going to end up with problems in the study. So, again, study people aren't to blame. They do the study. They get a grant. They do whatever. That's the way it goes. It's the people that take the study and take, they A equals B, B equals C. So A equals D. It's not, no, it doesn't work that way. So that's, they take this hypothetical syllogism, and next thing you know, they're saying, well, geez, no use me wearing blue light filtering glasses because it just, they don't work. Folks, there's no, and they're saying, oh, well, there's some harm in that because it messes with the circadian rhythm and whatever. Really? Because I've been wearing blue light filtered glasses now for going on 10 years, and I don't see any problem with my circadian rhythm. But hey, that's me again, anomalous, whatever you want to talk about. I think sometimes people, they want to make an issue out of something that's not an issue. So that's what's going on with this, with the idea behind the idea behind let me say it again. Studies should be to try to get a statistical probability aspect, right? And we talk about these statistical probabilities. Nothing is for sure from these studies. Nothing is for sure. It's just the statistical probability, the statistical significance of this stuff. So you have to be really careful about how that works. So let's move on. Enough of this. Let's move on about the $1 billion, the $1 billion weather and climate disasters. See how this is, NOAA. Now, like I said, this is, I really have trusted in the past, and I will continue to try to trust government data aspects. But this is just got some issues with this. This was shown on a media deal, and they're saying, we got $1 billion disasters, $1 billion disasters, and they're getting so bad. And it's, oh my God, it's going to be horrible. We don't stop this, we won't be able to. And then of course the reporter asks, is this sustainable? Well, what a question to ask. So of course the NOAA individual says, well, on this rate, we don't see how it can be sustainable, given that blah, 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 goes on and on. Well, come on, NOAA. By the way, I get no endorsements whatsoever from anything I'm covering here. So the federal government has nothing to do with this show. They don't endorse it. Trust me, they don't endorse this. So they got NOAA, right? Time series of this. And this was shown on the TV. This was all shown TV. Now, I want you to take a look at this. This is called CPI adjusted and unadjusted. CPI is cost performance index. And what this is, cost price index, whatever you call it. And it's done by the federal government. Interesting, right? So they take the federal government and they put it in the federal government anyways. So this is CPI adjusted, which means everything is adjusted to inflation. Now, I want you to take a look at this for a second. And I want you to take a look at 1980. Let's just pick 1980. 1980 has combined cost of $44.2 billion. There's one drought, one flood, and one tropical cyclone. This is 1980. Okay. 44.2 billion, one flood, one drought, one tropical cyclone. Okay, cool, right? I mean, this is a neat graph, and wow, everything is really wow. Look at this, woo, right? All right, so now let's go back and let's do unadjusted. We're gonna take a look. Unadjusted, so it's unadjusted for inflation, cost price index, all these things, right? And I want you to go back here. Now, remember 1980? Right? We had one flood, one tropical cyclone, one drought. Now we just have one drought. And the combined cost is $10 billion. Now, what's that 95% confidence interval? Well, 95% confidence interval, if you had, I'm 95%, if you did this over and 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 over again, a million times, 95%, you have a 95% confidence that it's going to lie somewhere between 7.1 and $12.9 billion. That's what that confidence thing means. So how did this, let's do it one more time. This is one drought. This is unadjusted. Now I go to CPI adjusted, and what do I have? I have, voila, I have one drought, one flood, one tropical cyclone, all in 1980. I didn't change years here. All I did was say adjusted to unadjusted. All right, let's take another one. Let's see if it happens in any other year. We're just going to take one at random here. So CPI adjusted, let's go to, let's go to 1998. So you have 4 severe storms, 1 freeze, 1 flood, 1 drought. Okay? Now, let's go to the next one here. Let's go to 1982. We'll just go 2 years from that. And 2 years from that, you have 1 winter storm, 2 severe storms, and that's 3 things. Combined cost of $5.2 billion. Okay, that's with it adjusted. Let's go to unadjusted and see what we have. Unadjusted, boom, we hit that. And what do we have? 1982, you got nothing. In 1982, now I'm going to 1982, nothing, $0 billion. All right, so let's go through this one more time. You have CPI adjusted, then you have, and you're going to go to 1982. 1982, 1 winter storm, 2 severe storms, and you have a combined cost of $5.2 billion. 1982. Now we're going to go unadjusted, and you have, let's see, wow, 1982, you have nothing, nothing, $0 billion. It's situations like that when you see this type of stuff that it puts the entire database, the entire data collection into question. What exactly does that mean? And just to make sure that I'm being fair here, let's go to 1998. Maybe they fixed this, right? So let's go to something that doesn't have too much. Okay, so right here, 1997, one severe storm, 2 floods. 1997, one severe storm, 2 floods. Let's see what the CPI adjusted says in 1997. So in 1997, what do you got? 1997, you got 1 severe storm, 2 floods. Wow. So all of a sudden, they must have corrected this somewhere along the line. Still, there's problems here. So NOAA, you need to fix your data stuff here. You need to fix your chart, because I mean that's ridiculous. And then so what I tried to do is I tried to access the data, and I tried to download the data, and I tried to set up my my own little Excel spreadsheet. So I did basically a cost of disaster, and what I did was I got their cost of disaster from their summary, and I have all the different references here in case you want to see it, right? I mean that I looked up, whatever else is going on there. And then I did what I call a density analysis. I said, okay, what is it like per capita? If I have, so what I did was I got the population of the United States in 1980. I got the cost of the disasters, which was $19 billion. And my density is about $83 per person, whatever you want to call it. And then, population rises. These, of course, are rising. Now, here's where the problem is right here, you have 2021, and that's the last portion done, they still don't have all the data there. So all they have is they just have a couple of disasters here, but they're saying 145 billion. This is average cost. This is not average cost. So it's they're trying to figure out what's going on here, but that's definitely an issue. So I mean, density analysis means what are we talking about with deaths? So very, very small aspects. And what I did also was I took the dollars, like if I took $10 million, I could actually go to the inflation aspect, and I figured out what the inflation was. So if I have the inflation here, if I go to the factor times the damages, 19 billion, I came up with $74 billion here, adjusted. They're saying it's already adjusted. So by adjusting it, I probably double counted that, but I did that to everyone. I did that to all of them. So then I went in, I took inflation data. I tried to do stuff with that. And then I took a time series. And this also is weird. So this was, this is very strange. So this is 1980. They're saying it was one drought. The drought cost was $39.3 billion. $39.3 billion. Now, this is CPI adjusted, right? This is CPI adjusted. So this is, that really struck me, and this is a download from NOAA. So, I mean, there's a lot of weird stuff going on here, and I just, I'm trying to come to a head with it, but I wanted to just hit you with that today, and then try to, maybe you guys can do some data searches or whatever you want to do. But the bottom line on this whole thing is that you just got to be careful about making sure that you check the data. Now, I say that at the beginning of the show, every time, at the end of the show, check the data. Check it, verify it, go down deep and, figure out, is there inconsistencies? What are those inconsistencies? I just showed you some here. Now, I'm sure NOAA would come back and say, well, that was 42 years ago with 1980, 43 years ago, we're trying our best here. And I get it. Just have consistency in data. And that's what you have to have. If you don't have consistency in data, then there's some flaws there. Now, those flaws could count into some bias or whatever else you have. So that does it for me today on the data show. I just want to hit those two things for you real quick, and wish you the very best for the rest of your week. And as I say all the time, please, 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 the media says something about some data study, go check it out. Go check it out. Don't sit there and take their word for it. I never, ever, ever, ever take the media's word for much, if anything. I go and I check it just to make sure that, because at one point there was a media about Tom Cruise going to, getting his award, the one award he got for Maverick, for Top Gun Maverick, in a jet, and it showed him in a P-51 Mustang, and I thought, somebody let that through. Not cool. You guys just take care of yourselves, and always remember, when it comes to the data show, you've got to check the data.